Hi and welcome. This time around we have another interesting project. It's also for the laser welding company. It's for fixtures for helium leak testing. And the whole point of helium leak testing is you want to see if the welds are basically airtight, except you're checking it with something like helium, and helium is a very small atom. So these are fixtures they had before, but they only worked so well. The bottom of this fixture, this part, goes into a gasket, an O-ringed receptacle that holds this fixture, and then it pulls a vacuum through this hole on the bottom and sucks vacuum, say, out of here. And here's an example of one of the parts. This is before it's welded. It's a stamped piece of metal. Then they weld on this part, and then two of these. And if you're wondering what these are, you might have guessed already. They're for sealed, hermetically sealed battery packs, specially designed battery packs. This, I think, is a vent, and these two are where the terminals go. So these need to be hermetically sealed. And this is a fixture they had, which is missing the plunger thing to push down on this. But this design presents some problems. I'm trying to get this out of here. So there's O-rings inside each of these cylindrical areas that make the seal. And that alone can be problematic to make sure you get a good seal, because remember, helium's an extremely small atom, and so it can slip by very small gaps. On top of that, you need the right material. So I hope these are viton O-rings in here, because other plastics are kind of, you know, like a sieve to helium. For example, silicon sealer. You think silicon sealer is great for making things watertight. Helium goes right through it. It just diffuses right on through. So when you're looking for one part in a billion, it only takes, you know, a couple atoms to get through, and the detector finds it. And then you have to, I think their spec is like 5 × 10⁹. So you can have 5 particles in a billion of helium are allowed to get through. So this design with the seals this way seemed like it was problematic. So I'm actually redesigning this the other way. Now, this is not exactly true. This actually goes across. A better representation, I just did this for visibility. Better representation is like this. So this part will fit this way down rather than this way. Oh, by the way, one more thing. So when this is held into the part like this, you have to block all of these holes. And they were just using like little silicone corks like things that would fit in there, probably for painting. And the problem is helium was getting through, because you need to be able to spray this. So you pull a vacuum on the bottom, and it needs to seal all the way around the bottom. And then helium is slowly diffused along the top, or let out of a, you know, like a tube on the top. And if it gets pulled into the vacuum, then the vacuum inside there is a spectroanalyzer detector that can pick out individual atoms of helium. So trying to seal this top part when it's facing this direction is actually really challenging, because you can't just cover this whole thing, because your whole goal is to check the weld. So you can only be on the inside. And so making a plunger that would go just on the inside and seal adequately on all 3 of these simultaneously seemed like it was more problematic than this direction, because on this one, they've got a little cap they can put over this one that'll seal it. And then these two, we could press down something right along the top, and it would still give you access to the whole weld area on all 3 parts. So I opted to rotate this around. So this is the top looking down, and it will have some viton foam sealant on the bottom, and this will press down into that and hopefully seal along the whole bottom. It's a really odd contour, and it'll be relieved, so it'll be larger than these holes here. And then it'll have a press piece that presses down with viton seals, which viton is a fluoroelastomer, and it's very good at keeping helium, you know, out. So that's what we're going to try. So it's a different design, and it shouldn't be too hard if it works. The question is, will it work? And I don't know that yet, because I have very limited experience with helium leak detectors. I know that it can be very challenging. I've watched them do their work and trying to get, you know, 4 or 5 × 10⁹ leakage is really challenging, and they never know whether it's, you know, you've got an imperfection in the weld. They had some here that were failed welds. No, it's not that one. I have a couple failed welds here where actually you can see light through, so obviously those are leaking like a sieve. But on top, like this one's not great. I think that one's mostly at an angle, and it warped the whole thing too. This is the one, I think. Yeah, this side here, they blew through. So this part right here, the laser blew all the way through, and you can actually see light through there. So clearly helium will go right through that. Another thing about this welding is they don't add filler material. So all these laser weldings, they have some little material that's proud, and they melt that material into the other material. For all the ones I've seen, I haven't seen them add any material yet. So we're going to take this chunk of material, turn it into something that's sort of like this, but the opposite. This doesn't look very impressive at all. This is Viton foam, and it looks like just cheesy closed-celled foam, right? This little piece was like $150. This tiny little piece is like $150, so we'll try and be sparing with it. I'm hoping this foam will work. I'm going to put this on there, and then atmospheric pressure will be 14 pounds per square inch, and this stuff is very soft, so I think it'll sit in there very nicely and should seal pretty well. And I will cut some holes out in the middle that lets the vacuum access all the way around the welds on all three of these parts with a little bit of extra space, and hopefully this will work. And then another pair of Viton seals will come down on the top, and then they'll put a cap on that, and that's what we're going to try and do. So we're going to turn this into our fixture. I'm going to remove a bunch of material just by sawing it off. All right, so rather than start off with a block that's already dimensioned accurately, and actually this one's undersized in multiple dimensions, but it's okay because the outside dimension, the absolute outside dimension of this doesn't really matter. I just needed a lip just to locate the part, really. It didn't even have to be there for the most part. So what I'm going to do is everything's going to be based off center line, which is a good trick. That way your absolute dimensions don't matter, just everything relative to this center line and this center line go in this direction. And so what I'm first going to do is I'm going to clean up the Z, and I've got this long end mill in here because I'm just going to walk it along the outside to square up this part. That'll make all of this top part relative to each other perpendicular, and it saves you a lot of trouble and gets things pretty accurate. So first I'm just going to deck this guy off with just a 20 thousandths pass, and we'll clean up the top, and then we're just going to go along the outsides and square it up. Then we're going to hollow out the inside all relative to the center line again. So I originally planned for 1/4 inch sides, but that was just an arbitrary number. Actually, I should have chosen something smaller because this, you know, this material is 1.25 thick, and I chose 1.256. So you'd have to buy the next size up material, which makes no sense if you were actually going to make more of these. Something to think about when you're working on this. This top squaring off doesn't really matter a whole lot either. I just want a reference surface, so that's what I'm doing. And there we go. Set my new Z knot. I could have used the end mill with a shorter length of cut, but I didn't have one. That would still do 1.5, well, over 1 1/4. So that's why I chose this. So now this top, all of these top 5 sides are all very square to each other. If you were going to use this method to square a regular part, and then you wanted this bottom parallel with the other sides, you'd deburr all of these edges, you'd flip this part over, and now that 5 sides are done, you just face the remaining side to the final dimension and you'd be good to go. It's a pretty cool way to do things as long as the head of your mill is trammed in pretty accurately. But that always matters to some degree. Next up, I need to drill 3 holes. One needs to go all the way through, which will be down the center round part. All of this bottom is going to get taken over to the lathe and turned into a 1 1/8 inch diameter shaft. So I need this one to go all the way through the center, so I've got a parabolic drill in here. It's bigger than my drawing, but again, that doesn't matter. It just has to be big enough to be outside the dimensions of the weld. So we've got an 8.2 millimeter drill bit, because I had it in parabolic, which is good for drilling deep holes, especially in soft material. Boy, that goes through it like butter. I run out of quill travel, I think. Yep. All right, through. And we're done with that side. So that drill bit I just put straight in an R8 collet, because that way I could deal with the fact that it was so much longer. And now we're ready to go on and drill the bigger diameter holes on the outside of each one of these guys. All right, so next up I want some relatively flat bottom holes. I've pre-drilled the center. Both of these holes need to be, well, they need to be 1/2 inch, but I'm gonna go 0.625, so I'm gonna do 5/8. And I've got my 0 set here. And we're just looking for 0.4 inches. The exact amount actually is, again, not really important. So now, if I want to clear out some extra material, I already have this end mill in here. I could start with this 5/8 end mill and then finish up with a 1/4 inch, so I could remove most material with the 5/8. Just got to do some calculations real quick. All right, so now I got a 1/4 inch end mill in there. We can go much higher RPM with this guy. And I'm gonna use the knee to plunge on this one. I'm gonna go in each corner and plunge them first. I'm gonna plunge, cross over to the corner. I'm not exactly on spot. I wanna plunge first in case it wobbles. So here's 1,000 RPM. Just come across, I'm a couple thousandths shy of the final size. Hopefully that's a better look for you of what's been done. So this bottom deck is pretty darn flat, which is good. Got to deburr these edges here because they're a little sharp. This hole goes all the way through. These holes just go down. We're going to drill a hole through the side over here, all the way through to this hole over here, through all 3 holes, and then I'm going to tap it and put in a set screw with some epoxy to seal it. and that'll connect all those pathways together, and we should be good. Let's see how one of those plates fit. Now I purposely cut this 50 thousandths large on each side. That was intentional. So this slop here was exactly what I intended. So this was just so that your part would sit on the foam, oriented over the holes mostly accurately, and I've got enough side-to-side play. The holes are big enough that even with side-to-side play, it'll still line up. We're going to cut out a piece of foam that's going to fit in here with the appropriate holes, and that will apply the vacuum to the bottom of this. Then you will put the helium along the top here. Over this will be foam, so this will sit up here until you apply the vacuum, and then it's going to suck it down into this groove here. And I think we're good here. Now we're going to drill the cross hole that we're going to tap ultimately, and it's going to go down all the way through to this bottom hole. All the way through, you can see it through the bottom hole there, and we're good. Just need to tap this, put a set screw in it with some vacuum safe epoxy. Next up, rotating orientation. These are two mounting holes for the clamp holding block that's going to be mounted to the side here. These are going in 1/2 inch deep, and they'll be tapped. All right, so here's this part mostly done. Before I turn the post on this guy down here, I'm going to use the bandsaw to remove the majority of material so I don't have to do so much of an interrupted cut. Load this up in my 4-jaw, using the center here to hold the part in place. I've got a parallel under it. Even though this is brass, it still might ding the aluminum. I might have wanted something flat instead, but... And this doesn't have to be super precise as far as its exact location. Wow, okay, that's in there. I did a good job. That's really tight. All right, so we're gonna try and turn this guy. It might not hurt just to add a live center so that the part can't come towards me in case it gets loose for some reason. Looks like it might be 1,000th under. That should not be any problem at all. Next up, we need to make the bracket that mounts on the side of here that will stick up above, proud, that will have the clamp that will hold down the part and seal off 2 of the 3 holes. So we're going to make it out of this piece of material here. We're going to use the same technique. We're going to go around the outside to square off the sides. First, we're going to run across the top, then do the sides, and we should be good. Cleaning up the bottom profile, not that I really need to. Could have left it saw cut, but you got to have a little pride, right? No one's even going to see it. All right, again, we're going to use the center line in both directions to determine our part positioning. That way the absolute width and thickness don't matter. So the fact that I actually measured those carefully, completely irrelevant, because everything's based off the center line. Next up, it's drill and tap for 832 in 4 spots. Now when I was laying this out, it turns out I set these 2 holes are what mounts it to the main piece. These top 4 holes are for the clamp. I put them right in line with each other. Not that it's going to matter because I was only interested in threads for about 1/4 of an inch into the material, so we should be fine. This hole goes all the way through, and there's another one opposite the center line that goes all the way through relative to the top. So this one's not relative to the center line in the y-axis, it's only relative to the center line in the x-axis, because I needed to know relative to the top because that was important. Guess I can test this once more. I don't know how easily you can see that. You can just sort of see under here, but that's sticking out 3/8. And if you're lucky enough to be working on a non-ferrous material like aluminum, then getting the screws out just takes a little magnet. Very easy. Figured as long as I'm here, I might as well give myself some additional options since this is a prototype and I'm not quite sure how everything's going to work out. So we're going to drill a second set of holes. All right, so let's assemble what we've got so far. We'll figure out the crossbar after we got it assembled. So this guy goes on here, and initially I'm going to bias it up because I think I'm going to need the extra space for this guy. I could go down here, which would be perfectly flush, but we're going to go up just a little. By the way, this did not go all the way to the bottom on purpose because I wanted this fixture to be able to sit flush in the mechanism, which would be down like this. So I didn't want there any chance to be an issue. Okay, so I was trying to figure out whether or not I should have the bar go on the top or on the bottom. Obviously it'd be stronger on the bottom, but I didn't know if I would actually have room. If the bar is thin, it'll fit on the bottom. If the bar is thick, it'll fit on the top, depending on how I want to do it. I also might want to just do some discs that would hold some foam that you could unscrew to get the depth exactly right so that when this tightens, it'll put pressure. There's actually going to be a 1/4 inch of foam down in the bottom here, remember that. So this is going to sit up here and then squeeze down. I could have the part come from underneath, but relieve it so that a lot of the material comes up above and it's notched where this is for left-right adjust. That's a moderate amount of space in there to make some discs that would fit in there. And then this will completely pull out of the way to pop the part out, put the next part in, and tighten it down. I also was thinking about a way of making a cap for this, and I think I have an idea that I might try as well. Give that one a shot too. Although the vendor did say they had some caps for this, that they, at least they thought they did. Found some material for the crossbar. We're going to notch it about 200 thousandths, maybe a 1/4 inch. We'll go halfway. We'll go 1/4 inch, and we're going to notch it 3/8 inch wide, which should be just the right width to fit that bar. You can sure tell that's stainless steel. That is just mushy. That is horrible. Just try 25 thousandths. Gonna use a chamfer mill to put a light chamfer on this guy. There's 10 thousandths. 10 thousandths is good. Still have a burr on the one side, but we got 10 thousandths. Gonna drill and tap for 10/24 in the middle, 2 1/4-20s on the side. Okay. Now what I'm gonna do is rotate this part 90 degrees. It's symmetrical. And I'm gonna put this part in the same spot. And then I'm gonna drill some 10/24 holes for set screws. This is the kind of set screw I'm talking about. If you can see that, they have a little plastic tip on the end and it'll lock the threads of the other screw in place. So those are gonna be height adjustable and I wanna be able to lock in place. So we're gonna use 2 of these guys. So we're gonna come in from the side. We will tap this side first and then go the long way, which is more important that the threads continue. Okie doke. All right, so I screwed this guy on here. We just need the pad holders that screw in the bottom here. Let's head over to the lathe and make the two pieces that'll screw on. So going to be 1/4 Allen head cap screws going through here, and then some pieces of steel that 4340 is what I've got in this dimension that'll screw on the bottom of that screw, probably Loctite it, and inside and on that will be the foam or nitrile or viton rather that will press against these to seal them. Now what these pads are going to do is I'm going to partially thread them so that the 1/4 will go most of the way through, just not all the way through. And then one side of it will get a foam pad. And you know, I wasn't thinking, maybe I wanted the one side solid, so I wanted to have it drilled to a stop. That might have been a better idea. I don't know if, well, there's nothing that's going to press in the middle. This should be okay. I was worried that maybe we'd perforate the foam or something in the middle, but I think we'll be all right. All right, so I just put this on loosely here. Haven't cinched it down yet. Although this is not the stiffest design, so I'm wondering if they have another model of this. That's not terrible. It's a little bit of twist this way. Hopefully it'll be mostly equal pressure. Okay, so might have to adjust that still. So we're gonna prep the ends for Loctite by removing the manufacturing lube by spraying some alcohol on and cleaning them off. All of these holes have already been cleaned with alcohol as well and sprayed out with the air compressor. So, which side? Looks like this side the threads didn't go all the way. Let's see. Wow, that's kind of weird. It's at an angle. Threads do stop, but it's like it wasn't tapped in a straight line. Yeah. I think I should tap these on the lathe next time when I hand tap them. They're not great. All right, let's see. Will that give me enough range? Yeah, because there's no foam on it at all yet. Yeah, so we'll remake these two pieces because when I hand tapped them, I did not get them dead perpendicular and they're not good. So on these two guys, I remade them. Here's the original two. So these guys, the threads go all the way through, and I did them on the lathe so they're straight. To stop the threads from working at the end, I'm going to use the old technique of displacing material at the back. Alrighty, and you'll notice these guys spin on a lot straighter. Alright. There we go. Alright, now we just need to cut out the foam and mount it. Hopefully, we'll have a working fixture. Here's my first go at the Viton foam cutout. I'm sad to say that I wasted this one because I didn't get those holes centered, so I had to reprint out a new sheet to make a new one after this. But the holes came out great, and that's this Mayhew Pro hollow punch set, which works amazingly well. Can't say enough good things about it. Used on a bunch of different projects. Definitely worth having. The mat on the table here is a cutting mat. Actually, it's 3 layers of cutting mat, so works fine. So now I reprinted another one, and there's 1/4 inch radius on the corners. I made the circles, the diameter, the much larger diameter than the original parts. Over here, they're 1/2 inch, for example, right there. But over on the other side, it's 9/16. So the center hole is 255, and I made that one 3/8, which is the punch size I'm using. So that's what I did so that I could line the punch up. So basically I take a piece of tape and run it across the paper after I cut it out, and then just tape it on the foam and then try and cut it. The problem with 1/4 inch foam that's really soft like this is that it squishes, so it's kind of hard to get a straight line on it. A bit of a trick. To cut the foam, I'm using this Japanese razor knife. It's one of those extendable ones where when the tip gets dull, you just break off the tip and you get a brand new tip. It's kind of like X-Acto Sharp, except I find these to be even sharper. This particular one, you'll notice the angle is really shallow, although there's still a piece of the broken tip of the previous one on there. I just left it. But it's amazingly sharp, and the cutouts work out really well, as you can see. All right, so here we go with the shipping box sealing tape. It's 3M box sealing tape, which I buy at Costco. It's a lot thicker than a lot of the shipping tapes, especially like U-line. That stuff's crap. Super thin and breaks really easily. This stuff's much thicker, and it works better. Unfortunately, the adhesive sticks to the Viton really well, so at the end of it, it's actually kind of hard to get off. And I discovered that after the fact, but it does a good job. Then I just line up the punch with the stencils I made, or the pattern I made. I guess better call is the pattern. And it punches out just perfect rounds. It's pretty amazing. As you can see there, which is how I made the rounds for the top part, the presser plates. So as you can see, I could have used these pieces and they would have fit, but they didn't give you much latitude. The only thing I discovered at the end of all of this is that I think that using 1/4 inch material is a bit much, that 1/8 inch would have been more than adequate. So I've bought a sheet of 1/8 inch. Also, I'm not sure that I trust the adhesive. Supposedly it's an acrylic adhesive. And when I went and tested this today, I found that maybe that's where it's leaking. I got 10 to the -8, one part in 10 to the -8, which is 1 in 100,000. 100 million, which is still really good. It turns out that these parts only have to be 1 in a million, one part in a million. So it passed, but they really would prefer their fixtures to be able to do 10 to the -9th, which is what I started out. I didn't realize that wasn't where the requirement for this part, but they shoot for all their fixtures to be able to do 1 in a billion, one part per billion. And so this one's not quite cutting it. So I'm thinking about switching to thinner material, and I may try even solid material. The Viton, not the Viton foam, but plain Viton. I just don't know if it'll form to the plate well enough to seal, so that's a bit of a concern. Next up, we're just going to cut this guy out, and I'm a lefty, and it looks really awkward when I see left-handed people do things, and I'm left-handed. I'm so used to seeing everyone else being right-handed that it looks weird when someone looks like me. Anyways, I do not have great hand-eye coordination, so cutting this out, in addition to not having great hand-eye coordination, the foam tends to move as you're pressing down on it. And so even though it looks like I'm getting a nice straight line there, it turns out it didn't cut very straight after all. Once it's cut out, we should do a test fit. Well, actually, I already did a test fit. So just going to press it in place. Got a nice shot of the back of my head here. I know. Got a nice back of the head. So the acrylic actually sealed everywhere but in the corner. I'm using one of the plates to push down on it just to see how it lines up and press it down. And it turns out one corner of the acrylic adhesive did not adhere particularly well. So that might have been why I was getting a tiny bit of a leak. I could only get 1 in 10 to the 8th. Oh, also I need to mix up some epoxy to put in that plug, or I'm going to get a huge leak. The epoxy I'm using is Loctite EA1C, and when I looked for it, I did a search based on what kind of epoxies can be used in high vacuum situations. Now, that just means it doesn't outgas a lot. That doesn't necessarily mean that helium won't permeate through it. However, I have to trust that since you can use it to seal a vacuum, then it won't let anything into the vacuum, including helium. This is a piece of Viton that's 1/4 inch thick, that's solid. And I wanted to use that, but it is so rigid you can barely squeeze it at all. And I didn't know that it would conform to the shape enough to get a good seal. That's why I didn't use it. Maybe 1/8 inch would be better. I don't know. I bought some to try. It wasn't very expensive. That was only $28 rather than the $150 like the other piece. So I'm going to hang on to this, and I'm not going to use it this go around, but maybe next go around. So I just mix up the epoxy. It has a 20-minute pot life, and I'm just going to squeeze some inside the hole where the threads are already. And then I will roll the set screw in the epoxy as well. What I really want is to get a good seal. I don't want it to leak here. And I think I did an adequate job. I don't think this is where it was leaking. Whatever leak I had was pretty tiny. It's not like you could hear it. 1 part in 100 million is still pretty good. When you sprayed helium, sometimes before the part had really settled, you could get as bad as 1 in 10 to the 7th, which is 1 in 10 million, or 5 in 10 to the million, because it was like 5 parts in 10 million. So I just rolled it around, and I got it deep in the threads on the part and the set screw itself, and then I'll just clean it up and we'll move on. Here's a close-up of the part, just checking for fit. And then I want to take a look and see if it actually works on the leak detector. Here's a quick snippet of what the leak detector looks like coming up. Here's the leak detector. It's a big machine because it's got a spectrometer in it, most likely. This is where the sample goes. This is a plug that just comes out. Fixture goes in there. Readout on the screen. And that's it. There's a tank of helium that you spray over the part. Alright, so here's the final fixture. I'm thinking this 1/4 inch foam is too thick and that I should have gone with 1/8 inch foam, which I still can. I'm still curious about that. I think 1/8 inch foam will perform better. Like the 1/4 inch foam has too much of an ability to deform, which was something I actually was counting on for a while, but now I'm not so sure. So this goes like this, and hopefully they'll have a plug to put over that. I made this, but I don't have a grooving tool to go deep enough, and I can only go 55 thousandths in a side, and I really need to go in 70 thousandths or 65 thousandths a side, and I don't know that I can actually make one. So hopefully they will have something to seal this adequately, but I think we're good to go. That's it. Thanks for watching. Hope you find it useful. Hope to see you next time.